Good morning, everybody. Welcome back to another exciting week of chemistry. So today we're going to take our solution chemistry one step further. We are going to look at solution reactions, which incorporates using table F, being able to write formulas for compounds, and then putting it all together to find out if there's a precipitate. So there's a lot going on. So make sure that you are viewing the video, pause when necessary. If it asks you to look something up, make sure you have your reference table open to the table F solubility guidelines, and you want to have it handy to use the periodic table. All right, so let's get into the lesson for today. Once we know how table F works, we can get a better understanding of how solution reactions work as well. This is because once we know how table F works, we can complete reactions and we can predict which of the products, if any, will precipitate. So first we have to complete the reaction, then we have to predict if the products are going to precipitate. This incorporates a lot of chemistry. First, completing the reactions. We might need to remember how this process works. To complete the reactions, we have to use our periodic table and our knowledge of how compounds and solutions form. You have to remember that every solution reaction is a double replacement reaction. What that means is both compounds in the solution are going to switch partners and make two new compounds. Double means two, replacement means switch. Now, in order to do this correctly, we have to know how the switching partners is going to take place. And this is going to incorporate our formula writing, which you might have forgotten how to do. So we're going to go slowly as we proceed to make this process clear. We're going to review the swap and drop process for formula writing. Remember, we need our reference table and we need table F for this. So make sure you have these things out before we move on. Let's check it out. First, the swap and drop process. We have to remember step one. We have to look up the elements, and if a polyatomic ion is present, table E, we must look up their oxidation numbers. When we look up these items, we are then going to write the oxidation number above the element in the superscript position. Now, remember, all that term means superscript is if I was using a document and I had to put that in the right place, I would do format, text, superscript. But let me show you what that means for us if you've forgotten. Here we go. If I take a look at this information, A to the X and Y to the Z. In this example, we're saying that A and Y are elements or polyatomic ions. The X and Z are the oxidation numbers. Notice that the oxidation number is present on top. That's why we call it superscript position. Now here we're writing down the charge of what we find on the reference table. Once we find the charges and write them down, we then carry out the swap and drop process. So if we swap and drop, we're going to bring down the oxidation number across to make the new compound. When we do this, it should now be in the subscript position. Now, what does this look like? Once we find the charges and the numbers, we're swapping the number only. This gives us the correct ratio so that the overall compound at the end is going to be neutral. Take a look. As we said before, if A is raised to the X and Y is raised to the Z, and X and Z are their oxidation numbers, When I swap and drop, the Z and the X have to move positions and move locations. When we do this, it changes to A to the Z and Y to the X. Now notice what happened. The X on top of the A went to the bottom of the Y. Swap and drop. The Z on the Y went to the bottom of the A. Swap and drop. This will enable us to get the correct formula. And with the correct formula, we can predict if a precipitation is going to occur. Okay? Now, again, you may have to replay this over a few times before it makes some more sense before we go on to the examples. Okay? So if you feel you need to pause and re-look at steps 1, 2, and 3, please do so. Feel confident before you move on. Now, let's take a look at the other part of the process. Once we have our products, we are then going to use table F to find out if they're soluble or not. Now, we used table F in previous lessons, so you should be pretty confident with this process. If table F says that something is soluble, it's aqueous, which means it stays in solution. If the component is insoluble, that means that it's now a solid. And what happens with solids? They fall out. These are the things that will become precipitates. So now let's take a look at the entire process from start to finish with our examples. Here we have a reaction, AgNO3 plus AlCl3. Notice that they're both in solution. How do I know? They both have aqueous. So first thing, I need to remember this is a double replacement reaction. So my partners are going to switch. So I'm going to draw that in. My Ag is going to leave NO3 and join with Cl. The reason why this works, Ag is plus, Cl is minus. Only plus minus interactions are going to work. While this is happening, the Al, that is plus, is going to connect with the NO3 on the other side. Again, this is going to give us a plus minus interaction that allows us to make the compound. So I need to find out what is taking place over here. And I encourage you that once we go through these examples and we get to the worksheet, to try to do the worksheet the same exact way. First, pick out what's going to connect and then continue. So I know that the Ag and the Cl are going to come together. And I know that the Al and the NO3 are going to come together. Now, what do I have to do? Step 1. Step 1, remember, is look up the element's oxidation charges. So I can find Ag, Cl, and Al on my regular periodic table. Notice Ag is plus 1 right here. Cl is minus 1, right? And Al is plus 3. So notice where I found those, right in the top right-hand corner where it says oxidation states. Now, the NO3 cannot be found on the periodic table. That's because it's a polyatomic ion. So for that, I would go to table E. Okay, on table E, I'm going to find out that NO3 has a charge of minus 1. So when I go to table E, again, just to show you one more time, NO3 is right here, and it has a negative charge. So what that tells me is these are my starting points. That's step 1. Now I want to carry out my swap and drop process, and I'll move this over to here. And on this side, notice that they're both 1s. So that's going to give me AgCl. And on this side, this 3 is going to come over to this one. And that's why I put parentheses so I could see both the NO3 and the 3 coming across. and the 1 moves over. Remember, in chemistry, we don't have to write the 1s. If you want to, you can. But in our examples, the 1 will be implied if it's there by not writing it. So now I have my 2 products. So now the last thing in this scenario is then to look up AgCl and AlNO3 on table F. So AgCl first. Remember, on table F, these items are soluble, right? And notice Cl is soluble except with Ag. So I know if I go back to this that AgCl is not soluble. AlNO3, when I go to table F, notice NO3 is always soluble. There's nothing there as an exception. So AgCl is insoluble and AlNO3 is soluble. Now, what does that mean? My final answer, drum roll please, is going to be AgCl. Look what happens. I changed it from aqueous to solid. That's because we saw that it was insoluble. And AlNO3, because it was soluble, I kept it aqueous. So if these 2 things are my products, only the AgCl is going to be the precipitate. What that means is that it turns to a solid because it's not soluble, and it will fall to the bottom. Now, again, this is one of those things in chemistry where there's a lot going on. So again, you may have to watch this first example over and over and over again with the other examples to make it make sense. But let's take a look at a second example and complete the process once again. Here I have magnesium sulfate, MgSO4, and KCl, potassium chloride. They're both aqueous. So it's a double replacement reaction. So the Mg is going to leave SO4 and it's going to take the Cl. At the same time, the K is going to leave Cl and it's going to take the SO4. Remember, it's always going to be a plus-minus interaction to make things neutral. So now I do step 1. I need to look up Mg, Cl, K, and SO4. Mg, Cl, and K are all on the periodic table. Mg is +2, K is +1, Cl is -1. So I know where these 3 things come from. SO4 is a polyatomic ion. So I must go to table E and look up SO4, and SO4 has a -2 charge. That gives me all of the charges that I need. So now I carry out the process. Swap and drop. The 2 is going to swap and drop. The 1 swap and drop. I get MgCl2. The 1 swaps and drops, and the 2 swaps and drops. I get K2SO4. Again, that might take some practice. Feel free to pause, look these things up, make sure you understand why we're using these numbers and how the process works. Finally, I need to go to table F. I need MgCl2 and K2SO4. MgCl2. Chlorine is what's in the compound. And notice chlorine is soluble except with these 3 things. So that tells me that Mg is not here, so it's going to be soluble. K2SO4, sulfate, is on the bottom. It says soluble except with AgCasRBAPB. K is not there. It also tells me group 1, which is K, is always soluble. So in this problem, moving my face back over, table F tells me they're both soluble. So once again, I have to put this all together. So on the right-hand side of this reaction, it's going to be MgCl2 plus K2SO4. And notice they're both aqueous. The reason why they're both aqueous, table F says they're both soluble. So in this scenario, there is no precipitates because they're both aqueous. Again, you may want to watch that example over a few times to get confident before you move on. The last example I want to look at is lithium carbonate and calcium fluoride, LiCO3 and CaF2. So process, double replacement, I need to know what's going to go with what, plus minus. Li goes with F, Ca goes with CO3. Now I look up my charges. Li, F, and Ca are all on the periodic table. So Li, F, and Ca, Li is +1, Ca is +2, and F is -1. Li, F, and Ca. CO3 is going to be on table E. CO3 is right here. It's going to be -2. So that is where these numbers came from. So now I carry out the process, swap and drop. This one's easy, 1 and 1. This one, the 2 goes across, and the 2 goes across. So just like 1 and 1, I don't need to write the 2's out. If I did write the 2's, I could still get that correct, but I always simplify. Remember, that was called the empirical formula when we did our formula writing. Last step of the process, we need table F. Table F is going to tell us LiF and CaCO3's solubility. First, LiF. Notice Li is right there. There are no exceptions, so I know that's going to be soluble. And then I need Ca and CO3. CO3 tells me things are insoluble except with group 1 or ammonium. Well, the problem says it's calcium, but calcium is in group 2. So, being that it's in group 2, the calcium carbonate is going to be insoluble. So now we have to finish the process. I'm going to put these items together back up on top, and I'm going to change the state of matter to what is soluble or not. LiF is soluble. That's why it's aqueous. CaCO3 is not soluble. That's why it's a solid. And here, my precipitate is going to be CaCO3. Again, this is not a terribly hard concept to understand, but it does involve a lot of chemistry. So please feel free to watch this video several times. And if you have any other questions, please feel free to contact me and I can work things out with you. All right, now it's your turn. You can open the worksheet when you feel confident and complete the problems. Thank you and stay safe.